What if I told you there's a light show at the bottom of the world so powerful it can silence satellites, reroute ships, and paint the sky in colors we can barely name? Picture this. You're standing on a frozen shore at the edge of Antarctica. The air is so cold it crackles. Above you, the sky begins to move. First, a faint green glow, like a whisper. Then ribbons of violet and crimson start to curl and spiral, pulsing as if the sky itself is breathing. This isn't CGI. This isn't a dream. This is the Aurora Australis, the Southern Lights, one of Earth's last great natural mysteries. But what you're seeing is more than just pretty colors. It's the final act of a journey that began 93 million miles away. At the surface of the sun. So, how does a storm on the sun turn into a silent, shimmering ballet over the South Pole? Let's rewind. The story of the Southern Lights begins not with light, but with wind, the solar wind. Our sun is constantly exhaling a stream of charged particles, electrons and protons racing through space at 1,000,000 miles per hour. Most of the time, Earth's magnetic field acts like a shield, deflecting this invisible storm. But sometimes the sun has an outburst, a solar flare or a coronal mass ejection, and it sends a much stronger gust our way. When that happens, our magnetic field gets stretched and stressed, like fabric pulled tight. And at the weakest points, the north and south poles, the solar wind slips through. It funnels down toward Earth, following the magnetic field lines like rails guiding a train. When those high-energy particles smash into oxygen and nitrogen atoms in our upper atmosphere, that's when the magic happens. Think of it like a cosmic collision. An electron from the sun hits an oxygen atom. For a split second, that oxygen atom gets excited, it absorbs the energy, but it can't hold onto it. So it releases the energy again, this time as light. Green light if it's oxygen up to 150 miles high. Red light if it's oxygen even higher up. Nitrogen gives us blues and purples. Each color tells a story about what's being hit and how hard. But here's what most people don't realize. The Aurora Australis isn't just a mirror image of the Northern Lights. It has its own personality, its own secrets. Because the Earth's magnetic field isn't perfectly symmetrical. The South Magnetic Pole is offset from the geographic pole. It's actually located off the coast of Antarctica, south of Australia. That means the Southern Lights often form in a slightly different shaped oval than the northern ones. They can be more stretched, more dynamic. And because there's less landmass in the far south, mostly ocean and ice, fewer people have ever witnessed them. They are the shy sibling of the Aurora Borealis. More elusive and in some ways more mysterious, and the shapes they take tell a story of invisible forces. Those gentle glows you see at the beginning, scientists call them diffuse auroras, the calm before the storm. Then come the arcs and bands, when the solar wind strengthens and the magnetic field begins to twist. But the most breathtaking stage is the corona, when the lights are directly overhead and the rays seem to converge into a single radiant crown, flowing down toward you as if you're standing at the center of a celestial vortex. It's in that moment you realize you're not just looking at pretty lights. You're looking directly into the heart of Earth's magnetic field. The intensity of the display depends on the sun's mood. During solar maximum, the peak of the sun's 11-year activity cycle, the Southern Lights can be so bright they cast shadows. They've been known to interfere with radio communications, disrupt power grids in New Zealand and Tasmania, and even affect the navigation systems of ships and aircraft. Early explorers in the Southern Ocean sometimes saw the lights and believed they were a sign from God or a warning. Today, we understand the science. Satellites like NASA's Themis mission have captured stunning data showing how magnetic energy builds up and releases in sudden explosions, called substorms, that make the aurora dance and flicker. We can predict auroral activity with reasonable accuracy, but understanding something doesn't strip away its wonder. If anything, it adds to it, because when you stand under the Aurora Australis, you're witnessing a connection, a literal, energetic link between our planet and our star. You're seeing the result of a journey that took days across space, ending in a silent, elegant release of light 60 miles above your head. It's a reminder that we are part of a dynamic solar system, one that's alive with invisible currents and forces. The Southern Lights have guided Polynesian navigators, inspired Aboriginal Dreamtime stories, and humbled modern scientists. They are proof that some of the most beautiful things in the world aren't just beautiful, they're powerful, they're meaningful, and they're deeply connected to the cosmos we call home. Have you ever seen the Northern or Southern Lights? Tell us about your experience in the comments. We'd love to hear your story. And if you want to keep exploring Earth's hidden wonders with us, don't forget to subscribe to Wonder Explorer.